Work done in isothermal expansion. Isothermal, the condition is the wall should be perfectly conducting and there should be free exchange of heat with the surroundings. Now let us consider the initial pressure, volume and temperature of the gas is P1, V1 and T1, and when the gas is allowed to expand to volume V2, and then in that case the pressure, volume and temperature will be P2 and V2. Since the temperature remain constant, so we will take the temperature T constant for both the cases. Now since the force is being exerted by the gas on the piston during the expansion, so some work is being done, and for that force is equal to pressure into area. Now assuming that the pressure will remain same for that particular change, so small amount of work done dW is given by F into dx. Since we have assumed that pressure remains same for that particular small change, so in that case P into A dx. Now what is A into dx? This is area into length, so that is volume. So pressure into dV, that is equal to dW. Now in this case we need to find out the work done, and for that the volume is changing from V1 to V2. So work done is given by, then that total work done during the expansion will be given by integrating from V1 to V2. Since volume is changing from V1 to V2, so that is equal to PdV. Now for isothermal equation, we know that PV is equal to RT. Okay, and for that P is equal to RT by V. So putting this value in this expression, we will be having V1 to V2, P is RT by V. This is RT by V into dV. R and T both are constant, so taken outside. We will be left with 1 by V dV from V1 to V2. Since this is the formula 1 by x dx, and for that the integration will be log x. So accordingly here will be the integration will be log of V. So we will be writing here log of V. Lower limit is V1 and upper limit is V2. Now putting the upper limit minus lower limit, this will be equal to R2. This is log of V2 minus log of V1, or we can use the mathematical formula. In that case we will be having RT log of V2 by V1. So this is the amount of work done in case of isothermal expansion.